Hello everyone, my name is Jason Gregerson. In this video we're going to look at one of the bigger, longer, nastier trig substitution problems that really should incorporate a lot of the ideas we've been learning. Alright, so here's our problem. The integral with respect to t of 1 over the square root of t squared minus 6t plus 25. So our first step when we're doing these trig integrals is identify the correct form. But this one's already a little tricky because it's hard to see what that form is. It looks like I'm going to have to complete the square of that quadratic to really see the form. So we'll do a little side work here. I got t squared minus 6t plus, and I need something here. Alright, so how do I figure out what goes there? Well, I'm going to take my coefficient, the 6 here, divide it by 2 to get 3, and then I'll square that value to get a value of 9. So I have 9. But I won't be able to change the quadratic from my original problem, which has a plus 25 here, so I basically got to rewrite that 25 as 9 plus 16. Okay, that means this quadratic is going to simplify to t minus 3 squared plus 16. Okay, and then once I have it in that form, I can think about what the substitution is. Looks like I have something squared plus some number, and so what I really want, my I wish statement to make this correct substitution, is I wish that this t minus 3 squared could just be replaced by 16 tangent squared theta. So that's going to tell me what substitution to make here. Now, to figure out the actual substitution, I can now solve this thing for t. I'll take the square root of both sides to get 4 tangent of theta, and I'll just add 3. So I have 4 tangent of theta plus 3. So this is a lot of the side work. First, I completed the square to be able to identify the proper form, and then I chose the right substitution to make. All right, now let's plug in this information into our problem. All right, so that means I have the integral dt over the square root, and I'll write it now in my completed square form here. So this is t minus 3 squared plus 16. And then after I make my substitution, dt, we'll have to figure out what that is, but in the denominator at least, I'll get the square root of 16 tangent squared theta plus 16. Now, what do I do with that extra dt? Well, I know t is equal to this thing, so now I can calculate the differential. It should be the derivative of 4 tangent theta plus 3. So the derivative of tangent is secant squared, so this should turn into 4 secant squared theta d theta. And so I will plug that value in for dt. 4 secant squared theta d theta. All right, now I'm going to simplify, and I've plugged all my theta values in, and now I'm going to try to simplify this thing. All right, well, the whole purpose of the trig substitution was so we can get this simplification here. 16 tangent squared plus 16 is 16 secant squared theta. And so I'm going to take the square root of that, and so it looks like in the numerator I'll get 4 secant squared theta, and the denominator I'll get the square root of that guy, which will be 4 secant of theta d theta. So it looks like this integral simplifies to secant of theta d theta. All right, so now we have this integral, and this is one that should look familiar. You should have seen in the previous section or from the formula sheet attached to one of these homework assignments that we have this as a known integral. So you should be able to reference the fact that the integral of secant theta d theta is equal to the natural log of the absolute value of secant theta plus tangent theta plus our constant. All right, so now we have our integral value here, and now the only tricky part is we don't want our result to be in terms of theta, we want it to be in terms of t. So now we have to go in and plug our t values back in. So how do we do that? Well, I can handle the tangent of theta because that was related to my original substitution. So originally my substitution was that t equal this guy right here. So since t is equal to 4 tangent of theta plus 3, I can subtract 3, divide by 4 to get t minus 3 over 4 is equal to tangent of theta. So that's my value for the tangent. I'll write that guy over here, t minus 3 over 4. But what about the secant? To figure out the secant, I'm going to have to draw the trig triangle associated with this value of tangent and see if I can extract the proper value for secant. All right, so let's look at this trig triangle. I have a right triangle. I'll call this my angle theta. Tangent of theta should be the opposite side over the adjacent side. So I can write this as t minus 3 over the adjacent side of a value of 4. So if I have those values, that should give me the tangent of theta is equal to t minus 3 over 4. Now if I know those two legs of the right triangle, I can use Pythag to figure out this leg. So I know that 4 squared plus t minus 3 squared should equal that hypotenuse squared. So it looks like this side should be the square root of t minus 3 squared plus 16. And so that's the hypotenuse value. Now I can use that to get the value for secant. Secant of theta is 1 over the cosine of theta, and cosine of theta is the adjacent over the hypotenuse, which means the secant should be the hypotenuse over the adjacent. So the result would be 1/4 times the square root of t minus 3 squared plus 16. And that should be our value for secant of theta. And so now I can plug that in over here into my integrand. T minus 3 squared plus 16. All that stuff plus some constant value. All right, so to summarize, we can see that this problem really incorporated lots of the problems we've been working on. We had to first complete the square to identify the correct form. Then we had to make that correct trig substitution. We plugged it in, we did the algebra. We even got a tricky integral here that we had to recall the value for. Once we did the integration, we still had a little problem converting back over to original variable. And to do that, we had to reference the trig triangle. So this problem really brings it all together. This concludes this video. Thank you.